No one is safe.
All right, sorry about that. Hopefully, I just gave a quick review of what we did before we came back. We've got this database here. What I want to talk to you about now is the normalization process itself. Normalization is the process of basically just separating stuff out into separate tables so that you have something that looks like this instead of one big giant flat file. Right? There we go. Yep, we're good now. All right. I just wanted to make sure before we continued. All right. There's this nice little mnemonic device here called that you can use. All columns in a table should depend on the key. That's 1NF, that's first normal form. The whole key, 2NF, the second normal form, and nothing but the key, third normal form. So help me COD. Now let's talk about what each one of these means in detail. They build on each other, so you cannot be second normal form without being first normal form. You cannot be third normal form without being second normal form, and by transitivity, first normal form. So it's first, second, and third. They build on each other. The first normal form is, formally, is that every attribute, every column basically in the table, that's what attribute means. Every column in a table only has atomic values. What does atomic mean in this case or in this context? Atomic means indivisible. In fact, that's the original meaning of atomic, right? It's not dividable. We, of course, now know that atoms are dividable, right? They're made of like electrons and neutrons and protons, and then neutrons and protons they're made up of quarks and subatomic particles, et cetera, right? But the original original meaning of atomic meant indivisible, that it's one piece of data that you cannot divide it any further than you already have. It's helpful to understand these things with respect to how you can violate this first normal form. So one violation would be storing multiple emails as a CSV string. For example, email at a.com, comma, email at b.com, and comma, email 3 at c.com, right? If I just put those in, then I'm no better than the CSV file that I was trying to get away with, right? Away from, excuse me, right? Remember all these problems with flat files, CSV files, right? If you're just going to use a database to store information in a CSV format, then why are you even using a database to begin with, right? Now, I have used databases before that have stored things in a JSON format, and that's perfectly fine. In fact, Postgres encourages that because you can actually make queries on that JSON data using their language itself. So it is actually pretty cool that you can do something like that. But flat files, no, right? All the same problems, you're back at square one. To even pull this out, you'd have to pull out a varchar, and then you'd have to split it up based on the commas, and then you would have to process each token. That's not how databases work. Another violation, right? This is not an atomic value. There are 3 values stored here. But another violation would be storing multiple emails in multiple columns. So for example, what if I had columns, say, email A, email B, email C, right, etc. Well, first of all, where do you stop, right? How many emails are you going to support? Let's just say 3, right? Is there a relationship between these emails? Right? Is there a primary, secondary, tertiary, right? Well, what happens when somebody deletes the primary, right? And then there's a secondary, or there's no tertiary at all, right? Or there's some combination, some subset of those that is defined, right? Now you're going on a fishing expedition. Is email A defined? Yes. Okay, use it. Is email no, it's not. Okay, then go to email B. Is that defined? No. Then go to email C to find out what relationship you actually have here. You do not have a one-to-many relationship like we have over here. You have a 1 to possibly 3, sometimes 2, sometimes 1. And even if it's sometimes 2, sometimes it's the first 2, sometimes it's the second 2, sometimes it's the other 2, right? There are a whole bunch of different combinations that can come into play with that relationship. Whereas if you just spread them out and put them into separate tables as necessary, then you don't have this problem, right? If you conform in first normal form, that simply just means that you're spreading out all the data into separate tables that make sense. If you see yourself having a one-to-many relationship, that's screaming out to you, 2 tables with a relationship between them. And by the way, where does the foreign key go? Remind me? The foreign key goes in the child table, right? The table that has many records. Not in the other table, not in the parent table that has one person associated with multiple emails over here, right? Okay, so the foreign key goes in the child table, just remember that, right? Second normal form is that it has to be first normal form, and that no non-primary attribute is dependent on a proper set of prime attributes. Don't worry about that for now. Instead, just follow my advice. What's the pattern that we followed over here? What is common to every single table? What was the first thing we did in every single table? We have a primary key, integer, not null, named after the table. That gives you second normal form for free, right? Just having that primary key auto-generated, not null, you get this for free, right? What would be a violation of this? Well, suppose that we had a customer ID, a store ID, and a store address in one table, right? Now, first of all, does that even make sense from a normalization point of view? Should you be storing customer ID and store ID? Would you do this in Java? Right? Probably not, right? Instead, suppose that we did this and that the primary key was a combination of those two IDs, customer ID and store ID, so that this customer shops at that store for this transaction, right? But the store address is not dependent on the customer ID. It is only dependent on the second part. In other words, half of the key. Right? Going back to the statement here, no non-prime attribute column, in other words, store address, is dependent on a proper subset of prime attributes. In other words, this thing over here, a proper subset. You've gone sets and subsets, right, in 235. What is a proper subset? Here's a quick review. A is a subset set equal of B. Right? There we go. Means that A is contained in B, but A could be equal to B. Right? What if that's not the case? What if it's a proper subset? What would that look like? Have you seen that symbol there? Right, with the little line at the bottom? That means that it's a proper subset. There's something in B that is not in A. In this case, a proper subset is just one or the other of these things. Right? And this is a violation of that because the store address only depends on half of it, not the entire key. Remember Edgar Cod? 2 normal form is the whole key. 3rd normal form is nothing but the key. Right? So that would be a violation. In fact, store address, does that even sound like something that should be stored in the store table? Maybe, but maybe not. Right? That's going to be for you to decide with respect to your design. Should we have an address table or not? What's the relationship between a person and an address table? What's the relationship between a store and an address table? Right? I'll leave that up to you. Right? It is often useful and necessary to define combination keys, right? That is, keys defined by more than one column, right? But they should be secondary keys, right? Not primary keys. Remember that we did this with, I think, what was it, an account number? We made sure that that was unique. Right? We put a uniqueness constraint on that in our original database. Where is it? You can have keys, you can have indices, you can have uniqueness constraints. You can do all that. Just don't do it with your primary key on a combination of keys. Right? Don't make that your primary key. Okay. If you did that with the ownership table, what would it look like? You would not have this thing up here. Instead, you would have person and asset, and that becomes your the combination of those two things becomes your primary key. Don't do that. Right? Instead, be consistent about it. Use a primary key, auto-generated, and you never have to think about this again, right? And basically, you split everything out into its own table. You'll start seeing a pattern here, right? 3rd normal form is that it has to be 2NF, second normal form, and thus transitively 1st normal form, right? Remember transitivity, A implies B implies C, therefore A implies C, right? If you're 2nd normal form, then that means that you are already 1st normal form, right? So it has to be both of those before you can even begin to think about 3rd normal form. And the statement here is that no non-prime column or attribute is transitively dependent on the key. Now to understand this, again, here's an example. Suppose that we stored in our annuity example a number of terms in years, monthly payment. But for an annuity account, we're also storing the value, which is the number of years times 12, because 12 months in a year, times the monthly payment. Suppose that we were to store all 3 of those things, right? That's a violation. This storing value violates 3rd normal form. Why? Because the value can be derived from the other 2, right? If you really want the value, that's fine. Go ahead and calculate it. It's that right there. Terms, years, times monthly payment, times 12. Right? You don't need to store that value because what happens if somebody comes in and changes the monthly payment? Right? The monthly payment is now $100 less. they also have to update the value. Otherwise, these pieces of data go out of sync, right? And that introduces a failure point, right? And that's what I've got here, right? It gives you it introduces a failure point, I should say. Introduces a failure point. It introduces a possible data anomaly. If one value changes, then the other values have to change as well. What if you forget to do that? Right? Well, don't forget to do that by not storing it at all in the first place. Anytime you want that value, recompute it, right? So that it's always fresh. Right? I don't think we ever saw it in any of the any of this sections, like homework 3, but you definitely would not do that in a Java class. Right? If you were to do term years, monthly payment, you definitely would not store this thing. Right? For example, over here, let's open up that annuity and look see what it looks like. Right? Did we even think about doing this? Private double value. Right? And then down here, what would we do? This dot value is equal to terms times monthly payment times 12. And then instead down here, instead of just recomputing it every single time, we just returned this dot value. Now, this might have some use cases in some cases. For example, if this value is really, really computationally expensive to produce. For example, it takes maybe a minute to compute this thing. Yeah, sure. Go ahead and cache it. Store it so that you don't have to recompute it every single time you want it. But terms times monthly payment times 12, is that computationally intensive? Absolutely not. Don't store that thing. Because if you have, especially if you have an immutable object, something that can be changed, right? Now value is completely wrong, right? That's something more like a declarative programming language. Like for example, Excel. If I were to open up Excel right now, and I would say that here's cell A, here's cell B. Cell C is equal to cell A times cell B times 12. And if I updated this one up here, this would automatically be updated. But that is a completely different programming language paradigm. That's called declarative programming, or more modern way of that sometimes people refer to it is reactive, right? And entire frameworks are built on this, of reactive programming. In a web form, if you go ahead and change this thing up here, then all these things are changed down here, and it's all automatically saved to the database. It reacts to your user interface changes. Right? We don't do that over here in Java. We certainly do not do that over here in SQL, right? Because that would be a violation of third normal form, and we don't want that. Right? So there is a lot more with respect to databases that we're not going to cover, right? Because this is not a database class, right? For example, triggers. Right? Triggers are things that you can define that in the event of something happening. So for example, the typical use case that I see out of this is somebody goes in and changes their password. And that you update their password field. We'll talk about that, how to do that properly here in a second. But suppose that they come in and they change their something, right? And then you've got this other column over here that says it's a date timestamp, last updated, right? You can set up a trigger such that on an update, you can go ahead and change this to the current date. So it was last updated on this date. And you'll always have a fresh date timestamp for this, right? That's one use case. Another use case would be somebody comes in and creates a brand new user record with an email. We're going to go ahead and have a trigger that sends that kicks off a welcome message sent to that email and to verify that email. You really don't want to be doing that kind of stuff in the database, though, right? You can do triggers, but you should be very, very limited in what you do. We're not going to talk about multi-tier architecture, but what you are essentially doing is building a middle tier, or you built a middle tier with your last assignment. There's a model view controller MVC architecture where you've got this view that the user sees. They see the web page, they see the report produced or whatever. Then below that, you've got this middle tier that's responsible, or ideally responsible, for all the business logic. Then down here, what we're doing right now is the data tier, right? The model, model, view, and then controller in the middle, right? MVC architecture. If you go and start putting all the business logic in your database, you go and start putting all of what you would normally do in Java code over here, and you're sticking that down in the database because you've got this bunch of triggers and other stuff, then what's the point of writing a middle tier, right? DBAs should not have to be middle tier programmers. Middle tier programmers should not have to be DBAs. A lot of times you'll see people, especially smaller organizations or organizations that don't want to pay a lot of people, they're always hiring for full stack engineers, right? Full stack engineers just means that you're the only person and you're going to be doing everything, right? If you eventually get into a well-run organization, you're going to have multiple teams. One team is going to be responsible for database stuff. One team is going to be responsible for middle tier stuff. One team is going to be responsible for the iOS front end. Another team is going to be responsible for the Android front end. Another team for the web front end or whatever, right? You're going to be separating those responsibilities because you don't want everybody doing everything. You want specialization. Well, if all your DBAs are middle tier programmers and all your middle tier programmers are DBAs, now everybody's stepping on everybody's toes. Limit that kind of stuff. But you also have things called views, excuse me. This is read-only access to a table and or columns, right? Tables and or columns. So for example, I don't trust the Android team over there to screw up our data. So what I'm going to do is I'm going to give them a view of the data. They can query out the data and then they can display it on their Android app. But they're not going to be able to update the data. They're not going to be able to delete the data. They're not going to be able to insert data because I don't trust them to do that. That's the middle tier folks. I'll trust them. I'll give them that access. Those folks over in the Android app developers, no, they don't know what they're doing. I'm just going to give them a view, right? Another use case would be, suppose that over here in the person table, I stored all this stuff, but also a social security number. Social security number is not something that everybody should have access to. So consequently, I will give you a view of the person table, but only giving you this subset of columns. I'm not going to let you view the social security number, right? And you can do that with a view. It's a read-only access to a table or a subset of tables that you can do. You also have stored procedures, loops, variables, etc. So, did I spell that right? Stored procedures. Yeah, I spelled it right. I don't know why you're complaining about it. Anyway, SQL is a full programming language. You can do anything that you could do in a regular programming language. You can write functions and store those functions in the database so that you can call those functions. You can write loops. It generally defines, you define a cursor or something like that. You have variables that you can set and unset and access and do whatever you want with them. Again, I'm not going to show any of this stuff because this is not a database course, right? But you should be aware that they exist. Another issue that you'll come up with a lot is security, right? Do not store sensitive information in a database unencrypted or unhashed. Just this last weekend, I was judging for the Future Business Leaders of America high school kids. We're doing a bunch of app development, and so I had to judge 6 of them. I did it last year as well. But to get in to see the apps this year and to judge them, I didn't remember my password. So I had to reset my password. So I hit the reset button, and guess what? I got an email with plain text, my original password that I set a year ago. Thank God I did not set it to anything that I cared about, right? Because that told me, what were they doing? They were storing my password in plain text, right? Usually what I'll do is something like for FBLA only 2023 is what it was, right? The exclamation point. There's my password. Who cares? Because whatever, right? Why did I say it's only for that one? Well, it's because I knew that they didn't have great security measures. They were storing this plain text. They weren't storing what they should have been storing, which was a hash code of that. This is SHA-256, secure hash. It's taking this thing and producing this seemingly random hash code out of it. This is what you store, so that next time somebody comes in and it needs to log in, they enter their password again. You recompute the hash, and then you compare it to the stored hash. If the hash matches, then you grant them access. If it doesn't, because they mistyped, right? That's a completely different hash. We don't grant them access, right? There it is, right? Now, why do you do this? Well, because if anybody breaks in and gets access to your SQL server and you're storing passwords plain text, not only do they have access to all those users to that system, But guess what? Most people don't change their passwords. If somebody used this password, in fact, what's the most common password? Password, right? There it is. There's the hash. If you just do a Google search of that hash, it'll come up all over the place. Why? Because it's the most common. Right? Hackers generally will take the most common passwords, say 10,000 most common passwords, and pre-compute all these hashes and produce what's called a rainbow table. And then they'll take all these hashes. It's basically a reverse lookup. This hash will map to this password, right? And that is so common that it's all over the place, right? There's a hash. People find that hash all over the place. Whereas if you'd use some sort of random password, I can guarantee you almost that this hash will never show up on any searches at all, right? Yeah, like what? If I require it? There we go. Google is probably better for this since yeah, there we go. Not a single internet search indexed by DuckDuckGo has come up with that hash. Why? Because nobody has ever used that combination of keyboard mashing for their password. Right? And hopefully nobody ever does. Nobody would ever remember that, right? So don't store stuff in plain text. In fact, don't even bother with authentication at all, right? Offload this to a third party. In other words, like, say, Google or GitHub, etc. How many times have you gone to a website and you said you have an option? You can create an account, and it's that account for that system, or you can go ahead and log in using your Google credentials, right, and grant them access to that way, right? Do the same, right? Offload that complicated, very, very complex system of maintaining passwords, allowing somebody to change their password, two-factor authentication, all those bells and whistles, just like Google do it, right? They don't even charge you for it. I think using Google authentication is free. GitHub certainly is, right? I think it might be if you have a large enough organization that they don't let you do that, but GitHub certainly, right? So the solution, don't do it. Let somebody else do it, right? It's always the solution, right? The best engineering, the first question that an engineer should ask when solving a problem is what? You have to solve a problem. You're an engineer. Right? Again, engineers don't like to work. Right? Has somebody else already solved it? Exactly. This is why you use libraries. Has somebody already written the square root function? Yes. All right. Let's use that. Right? Has somebody already done this? Has somebody already done authentication? Let's just go ahead and use it. The last thing that I'll mention is soft versus hard deletes. Right? So a hard delete is when you actually delete something. Over here in MySQL Workbench, I've got a bunch of people. Remember that I've got myself, Babe Ruth, and LeBron James there. And if I were to go ahead and delete from person, first of all, it's not going to let me do that, right? Because I'm in safe mode. You can't just delete every record. But if I were to say delete from person where person ID is equal to 1, I'm not going to run that because I don't want to delete myself yet because we're going to use this data. But I can go ahead and delete that. That's a hard delete. That's what we call a hard delete, right? No undo, no undelete, no restore. In other words, even a restoration, you would basically have to run brand new SQL insert statements from an old snapshot of your database. That's what's called a hard delete. Now imagine you design a system where you're trying to protect yourself from your users as much as possible, right? The typical ID10T user. Have you ever seen that before? That's common enough. Everybody's seen that, right? The ID10T user. What does that spell? The idiot user, right? Where you've put up as many roadblocks as you can to encourage good behavior. You go and you design the interface so that they hit this button to delete something. A prompt pops up saying, are you absolutely sure that you want to do this? Yes, no. They click yes. Another prompt comes up. Are you absolutely sure that you want to do this? You cannot undo this, right? If so, please type your username, right, as confirmation. And so they type their username, and then they hit OK. Then they call you up and say, I actually didn't mean to do that, right? No matter how many roadblocks you put up, you're always going to have to deal with that ID10T user. So what you could do is what's called a soft delete instead. Right? What you could do is every record that you care about, or every record in every table that you could care about, you put in a column called isActive. It's a Boolean. It's either true or false. If it's false, that means that record is soft deleted, right? It's not active at all. If it's true, that means it is active, and it'll show up on any queries, right? You can write all of your queries to only pull out where is active equals true, right? Now when a user deletes something and goes past all your roadblocks, and yes, I am absolutely sure I want to delete this, you just simply set is active to false, right? So that when they call you up and say, I screwed up, I didn't mean to do that, you say, oh, that's too bad. I'll see what I can do though, right? And then you come back to them 3 days after and say, well, it took me the last 3 days, but I was able to find your records and restore them. All it did was take you 2 seconds of a set is active to true, right? But now you're the hero. And instead of, nobody is the wiser unless you've got engineers for bosses and they know what's up, right? Then you're screwed because you can't take 3 days to do one SQL query, right? But as long as you've got incompetent bosses, then you can and say, it took me 3 days, man, and I work 24/7, so I'll be putting those hours in and charging you $300 as a contractor here. But I was able to restore those records, right? Tell your users to be a little bit better in the future, right? I can't tell you how many times this has saved me, right? In fact, usually in a system that I design, the first couple of times, okay, yeah, I'll be able to restore that. Yeah, I'll be, no. Once you understand how stupid your users are, then you go back, okay, I'm going to protect myself and do soft deletes from now on, right? Just because I'm tired of dealing with those people, right? That can't read the instructions or anything like that, right? So that's a soft delete versus a hard delete. Don't do soft deletes for your project. It's not going to be worth it, right? This is something that you should do, maybe even consider in a real system with real users that you can't trust. But this is a artificial enough project that you're not going to have to worry about it. In fact, you're not going to have to worry about any of this stuff. I'm just telling you this because you should be aware that these things exist and aware that these issues exist. There are entire teams, right? My last job, we had the DBA group was, I think, 10 people. 10 people in charge of one master database, right? Why? Because it was so massive and mission critical. And they had so much to do on the database on a daily basis that they had to have that many people on the team, right? Because they weren't just handling the production data. They made sure that there were backups and that there was a test bed and that everybody had a copy for their own test. And then there was a pre-production version of the data, et cetera, et cetera. So it is an entire, you can become a DBA, right? In fact, that's another good acronym to remember. DBA equals database administrator. Admin, I'll say. There we go. That's better. All right, there we go. Because that's what they are. They're admins. They're DBAs, right? And then, of course, you've got an entire branch now that has just been birthed over the last 10 to 15 years, data science. Right? In fact, we have a brand new major as of last year, I think. Or no, this year. This year is the first year of the data science major, where they're basically DBAs, but with additional programming under their belt so that they can do stuff with that data instead of just maintaining that data. Right? So it is an important thing, and there's going to be lots of jobs in the future for this kind of stuff. We didn't call them data scientists back in the day. In my last job, we called them dweebs, right? That was just an acronym that we used. It was data business intelligence, I think it was. So it was like the dweebies or something like that. So we just called them dweebs. Data warehouse and business intelligence. I forget what it was. Anyway, we just called them dweebs, right? Because they were what we would call data science today. That they were writing Excel files and gluing things together with Python and Java and pulling stuff out of the database and doing all that kind of stuff. All right. So what we are going to be talking about next, though, right, not getting into databases any deeper than we already have, but we are going to be talking about how to programmatically connect to your database. Because unless you're a DBA, if you're a DBA, this is where you'll live 24/7 in some sort of IDE where you're running these queries all the time, right? You'll live in Excel. You'll live in whatever Python workbook you've got or something like that if you're a data scientist. But we don't like doing that because we like writing a program to automate stuff, right? I want to write Java code to insert stuff into the database. I want to write Java code to pull stuff out of the database to produce a report. I want to write Java code that can then be connected to by an API to display stuff on a web page. In fact, you'll be doing that not this week, next week. We've already written it for you, the web app for you. You'll be connecting to your albums database programmatically to display stuff in a web page, right? And then you'll be able to click stuff and go and get more information out of it. That's the front end. That's the model view controller architecture, MVC. That's the view part of it. But none of it works unless you programmatically connect to a database and pull stuff out, because an end user that's operating in a web page, they're not going to be writing a query like select everything from person, right? They're not going to know anything about SQL. They just want to see the data in some format. So we're going to write Java code to do that for them. Right? Today I'm just going to get you started since we are limited on time. But the application, or what we're going to be using to do this is called Jdbc, Java Database Connectivity API. And there are lots of DBCs, right? There's ODBC, Open Database Connectivity API. That's written in C, C++. There is, what does Microsoft call theirs? I forget what it's called, but there are a bunch of open database connectivity APIs. This goes back to the solid principles. Do you remember the SOLID principles? Do you remember the D of that? It was dependency inversion. We are not going to write code to connect to a MySQL database. We are going to write code to connect to this API. Right? The API will then be implemented by Oracle, or it'll be implemented by Postgres, or it'll be implemented by somebody. Right? The first step in doing that is to download that and install it. Right? So step one, download and install the connector.j jar file for MySQL. Let me go ahead and open that. Just do a Google search for it. MySQL connector.j. There we go. There it is. There's the URL, and there it is in your notes. There. Right. So what operating system? Don't select an operating system. Select platform independent. That's the whole point of Java code. Write once, compile once, run anywhere. Right? You don't. There's nothing specific to anything, any of these, except for like maybe some metadata stuff. If you're comfortable with tarballs, go ahead and do that. Otherwise, download the zip file. Don't sign up for Oracle spam. Just go ahead and start the download. Right, there it is. I'm opening it up as a zip file. There we go. There's the jar file you want. Ignore everything else. Right? Everything else is, there's the source. You can actually look at it if you want to. But all you're really going to want is that connector.j jar file. Now, like any jar file, you drag and drop. Oops, I don't have a lib folder, so let's do that. New folder, lib. There we go. And drag and drop. There we go. Yes, copy it over. And expand that out. Right click, build path, add to build path. We're ready to go. Right? Now, again, I'm not going to write code to connect to a MySQL database. What if I did that? MySQL connect. All right. What if I did something, that's not real code, but what if I did something like that? And I had now 10,000 lines of code that all connected to a specific MySQL database. Right? Now suppose that I don't like Oracle anymore. Right? Oracle now is charging for some reason. Instead, I want to migrate over to PostgreSQL. Right? Postgres is a true free and open source software SQL server. Right? There's its Wikipedia page. If I have written everything to a MySQL database, that means I'm throwing out 10,000 lines of code and starting over and rewriting everything from scratch. I don't want to do that. Instead, what I want to do is I don't want to change a single line of my code. Jdbc connector driver. Instead, I will download Postgres Jdbc driver. Right? And I will do the exact same thing that I just did, deleting this jar file and replacing that jar file. Not a single line of code changes. Why? Because of dependency inversion. I am not writing to a specific database. I am writing to an interface, a generic interface that's implemented by this jar file. Okay? So I'm not going to go down that road. By the way, PHP went down that road, right? I think it's like MySQL connect, like whatevs, right? You've got all these functions all over the place with MySQL connect, MySQL that, MySQL that, MySQL that. Guess what happens if you want to switch over to a Postgres database? GraphQL, yeah, something like that. You're going in and changing every single instance of all function calls. Right? Stupid mistake that they did a long time ago that people are still living with. Right? That's why you get the WAMP servers. Windows, Apache, M is MySQL, and PHP stacks. There's WAMPs, there's AMPs, it's a bunch of different AMPs. All three of those things are always packaged together because of those stupid mistakes. They're so tied together that they have very, very tight coupling. Remember, you want loose coupling so that you can take something, throw it out, and plug something in, and you're good to go. All right. We need to connect to the database. So what are the three things that you use to connect over here in MySQL Workbench? Let me go ahead and get rid of this. Right, let's go ahead and go with a new connection. What are the three things that you had to provide? Well, a name for the connection, blah, blah, blah. Who cares? Right? But what did you have to provide first? A host name. You also had to provide a username and a password. You have to do the same thing over here in Java. String, username. Well, what's my username? It's going to be Seberg3. Your username is going to be different. If you're working with a partner, you're going to have to choose one or the other and just go with it, right? String URL is equal to what was the name again of the server that you're connecting to? Do you remember? Sysy Linux.unl.edu, right? Well, what are you connecting to it for? Is this a web page that you're connecting to? HTTPS? No. In fact, I wonder, what is? Do they even have a web page, web server up there? Yes, they do. Your browser doesn't automatically. Okay. Oh, okay. It just redirects you. Okay. Back to our computing.unl.edu instance, which is a Drupal instance, right? But anyway, it's not a web page, right? It is a MySQL database. So we need a different protocol. What does HTTPS stand for, by the way? That's like high school computer science stuff, right? Hypertext Transfer Protocol. S stands for secured socket layer, right? ... whatever. Well, we're not going to connect to it for that purpose. Instead, we're going to connect to it for connecting to Jdbc MySQL. Right? That is a fake protocol that is used by the jar file to determine, oh, you're connected to a MySQL database. I know what to do now. Right? Otherwise, that's it. That's all you need. I tested it. Right? And then you need one last thing, string password. I'm not going to give you my password. Right? To do. I'll leave that for now. Right? Because, yeah, all right, fine. Do I, you know what? My compromise last one, I'm going to copy that and move that there. There we go. Instead, I won't show you my password, but instead I will store it somewhere else. Database info.password. There we go. I'm not going to show it to you. Not because I don't trust you, but because, well, I don't trust the internets, right? And however many people, 8 people are randos on the internet are watching right now. I don't trust them, right? This is why we told you do not make your password into something you care about. Because if you make it into something you care about, you are eventually going to be putting it into a bunch of Java code, right? But also, well, wait a second. If I'm storing my password over in some other class, why shouldn't I store everything over in into another class? That's a good idea, right? Database info should store all of this stuff with just one thing. In fact, you can take it to the next level. Instead of always reconnecting every single time, I'll make it into what's called a connection factory. I'll show you how to do that later. But for now, I'm going to show you how to actually make a connection. First of all, you need what? A connection. I'll call mine con. Right? And the driver manager is going to be responsible for getting that connection using the URL, the username, and the password. What is the driver manager? Well, it's this piece of code that is responsible for doing all that stuff, and it's somewhere in this jar file. Do I care where it is in that jar file? No. In fact, what is this driver manager? It's not even in that jar file. Right? It's an API. I am not programming towards that particular jar file. I am programming towards this API up here. Right? Java.sql driver manager. Java.sql.connection. Right? Let's go ahead and import that next. There we go. Import that. Did it do it? No, come on. Import. There we go. There. I don't think we've seen it too much in this section, but don't do that. Right? It's called a wildcard, and I've never showed it because it's bad practice. You are basically taking everything in that package and importing it all, right? Whether you use it or not, don't do that. Right? Make sure that you are only bringing in what you want. Connection. There we go. Now it's spelled correctly. Right? Otherwise, there we go. It's not compiling. And that's because any number of things can go wrong with your connection. What if you had a bad password? What if you misspelled your username? What if you didn't have an internet connection? What if the server was down? Somebody kicked out the power cord over in Nebraska Hall, wherever it's stored, right? I think it is in Nebraska Hall, but whatever. Right? Well, can you reasonably recover from any of that stuff? No. Again, this is a legacy of old Java, where they thought checked connections were just great, right? They made a mistake way back then that we're going to be dealing with now. Throw new runtime exception, E. Right? No, it's not a high schooler course. Right? I don't know who you are. You'll have to tell me what your real name is if you're part of this course, but whatever. Anyway, we're going to catch and release like we've done before. Just YouTubers talking. Anyway, we're going to rethrow this as a runtime exception. That's really pretty much the only thing you can do. Can you write code to go back over to walk over to Nebraska Hall and plug the server back in and start it back up? No. This should be a fatal error, so that if you do have a misspelled username, it ends up looking like this. Right? A bunch of where is the console? There we go. Right? SQL exception: access denied for incorrectly spelled username. Right? Was I using a password? Yes, and it's not going to show you what your password is used for security reasons. Right? Let's go ahead and see what a successful connection looks like. There we go. Well, nothing happened. Why? Because you made a connection. Did you do anything else? No. If you were to open a file, what should you do with that file? Close it. It is a million times more important now to close a database connection, because this database connection is holding network resources. It is holding memory on your computer. It is holding memory on the server side. And guess what? You're limited to 30 concurrent connections. So if you open up a connection, don't close it. If you open up another connection, don't close it. And you end up opening up 30 connections without closing any of them. That's it. That's the end of the show, right? Now you're no longer allowed to open up any more connections, and you're going to be waiting for maybe 5 minutes for everything to get reset. Right? So make sure that you are closing your connections after you are done. Unfortunately, you have to surround this with a try-catch as well. Why? Because still things can go wrong even if you're closing a connection. There we go. There. Oops. I should bring this up over here. Equals null. So initialize it. Get rid of that. Format everything. There we go. Now I'm opening up that connection, and it's just immediately closing it without doing anything to it. Right? What if I didn't do that? Let me show you what happens when you don't close the connection. Right? While true. I'm going to force this to go into an infinite loop so that I can show you what it looks like on the other end. All right, let's connect to that CSE server again and use my database. And I'm going to show process list. That's showing all the connections that are persistent, that are connected right now. There's that's the connection that I just used to list all the connections. So listing connections required a connection. This is probably one that's being held open by MySQL Workbench, right, just to stay connected. And then this is the one that's probably being held open by my Java program. Let's go over here and kill it. 9 times out of 10, especially if you cross your fingers and hope, right, it will end up closing it and cleaning up that connection for you. Right? It's that 1 time out of 100 that it doesn't, just like files, and the file ends up being corrupted. Over here, you do this 30 times. 4 int I equals 0, I is less than 30, I plus plus. Right? Now remember, I have already connected using MySQL Workbench, so this is probably going to fail on the 30th connection. There we go. I opened up 29 connections since I already had one open up over here. Right? The 31st became too much, and you already have more than the max number of user connections. Right? Don't do that. Always make sure that you're closing your connections, because if you just keep opening, and never closing, you're going to run out. In fact, what's it going to? Are they open still? Nope. Okay, they got reset. Cross your fingers and hope they get reset. Otherwise, you'll be waiting for 5 minutes or so to get for them to get reset. So it's a million times more important now to close your resources. We'll pick it up there on Wednesday.